Hello everyone. Welcome to the second live session of this course. I'm Gitanjali. I'm a research scholar from IIT Delhi, and I'm the TA for this course, which is Foundation of Classical Electrodynamics. So, to give a brief introduction, like I said before, during each live session, we'll cover whatever the concept that has been taught during this week. I will also try to solve few problems that is related to the concept of this week. And also, in the meantime, I will also try to clarify the different types of doubts you must be having or you may be having for this course. Okay, so let me uh, let us see a brief introduction of the lecture contents that has been taught for this week too. So my screen is visible to everyone, right? Let me know. Is my voice and the screen, if is everything fine? Okay, so if so, then let us start our session. So during this week, we first saw what are the different types of integral that we must come across during solving the problems that is related to electrodynamics. So the first kind of integral is the line integral, which is nothing but the integration of a function over a path dl. And the second type of integration is it's a surface integral, and the surface can be it may be open surface or it may be a closed surface. Depending on that, you can take the integration. So for open surface, it is a dot ds, and for the closed surface, we'll have to take a closed integration of the function over this surface ds. And the third third type of integration that we see is the volume integration that it's the integration of a scalar field over a volume V. And we see the different types of operator. One is the Taylor operator. So it acts upon the scalar function to give a vector function. Okay, so for Cartesian coordinate, we have the representation of a del operator like this. So this is like the unit vector and multiplied by with the dou by dou x or dou by dou y or dou by dou z. So the physical interpretation, it's like the delta t. It points in the direction of maximum increase of the function. So whenever you have a randomly varying function like this or anything like this, then to find out the gradient, so you must look at the direction at which the function is it's getting maximum. Similarly, similar to the Cartesian coordinate, in spherical or uh, in the cylindrical coordinate, we have a expression of the del operator. So you have to remember all this expression. So it's simple to remember. So what is the expression of a delta operator? For Cartesian, it's easy. It's dou by dou x, dou by one, dou by one, dou by dou z. But for the other coordinate system, like the spherical one or for the cylindrical one, what you have to do? So you can see this is nothing but the infinitesimal length element for in the row direction, and for phi it is the infinitesimal length element in the phi direction, and this is in the z direction. So if you know what is the expression for the small element in row phi in z direction, then you can easily find out what will be the total expression for a delta operator. So this is rho rho, rho dou phi, and dou z. Similarly, if you look at the spherical coordinate, so if you remember, for r theta phi, in r direction, it is a small element is dou r, or in that case, we have written dr. So for that's why here it is dou r. And in the theta direction, the small element is r d theta. So that is why we are saying r dou theta. And in the phi direction, it is r sin theta dou phi, the small element, small length element. So that is why this is r sin theta dou phi. So finding the expression for the delta operator in different coordinate system, you don't have to remember this. If you just know the length element in different direction, then you can easily find out what is the expression for the delta operator in either in spherical or in cylindrical or in Cartesian. So besides that, if you recall the lectures also cover how we can go from the XYZ coordinate system to the rho phi z coordinate system. So this is like expressing all these parameters in terms of the parameter of rho, phi, and z. So this is sorry. So this is just a small brief process like what the lectures have covered. So we have to express escape in terms of rho phi z, dou by dou x in terms of rho phi z, and other in terms of rho phi z. And you have to use this relation that we have seen also. The radius rho is square root x square plus y square, and x and y is expression like this, and phi is expression like this. So if you just use this formulation and use in the final expression, you can get how you can go from this expression to this expression. So the proof is also it's covered in the lectures. Okay. So now for the next part, we have seen what is the divergence of a vector, what is the curl of a vector. So these are different types of operators that we use, and we'll also see in future live session what is the physical significance of these different types of operator. So for divergence, it is if you take the dot of the del operator with a vector function, then you will get what is the divergence of a function, and it typically measures how the vector is spreading out from a point in a different in a direction. Similarly, if you take the cross product of delta operator with a vector function a, then you can get the what is the curl of a vector a in that coordinate system. So this typically measures how the vector function rotate around a given point a. And if you see that for a given function a, vector function a, you are getting the curl is 0. So in that case, we say the vector A is a irrotational vector. So irrotational, we'll also see this is also one of the definition of a conservative vector. So what are the different types of conservative vector? If you recall, if the total path integration, if the close integration, or if you go from a point A to point B through different paths, like if you go like this or go like this, if it doesn't depend on the path, if it only depends on what is the end point of this function, then in that case we say the function is a conservative function or the field is a conservative field. Similarly, so that conservative field, we can also say this is a irrotational field. Okay, so one of the definition of the irrotational field is it's a electrostatic field. So this is one of the physical significance of finding the curl of a vector function. Similarly, if you see, we'll see from the Maxwell's equation. So if you're getting a divergence of a vector field is zero, then we say monopoles doesn't exist. So if you recall, magnetic field don't have monopoles, so that is why divergence of B is zero. So this is one of the significance of getting a finding out the divergence of a function. So this operator do have physical significance. That is why we are studying these different types of operators. So the third kind of operators that we have, it's a Laplacian operator, which is nothing but the dot product of the delta operator with itself. So this is one of the expression of the Laplacian operator with in the Cartesian coordinate. So in Cartesian, it is easy to find out what is the final expression for the del square operator in Cartesian coordinate. Okay, so this is one kind of the formula. So this is the trick that you must use, that you may use to find out what is the total expression of gradient, call, or the Laplacian in different types of coordinate system. So for that, what I have written down. So this is UVW. It is nothing but the unit vector in different direction. So if you see in Cartesian, it is x, y, z. So u, v, w is u is x, v is y, w is. Similarly for spherical, u is r cap, v is theta cap, w is phi cap, and in cylindrical, u is rho cap, v is phi cap, and w is z cap. And the other type of expression that we have is f, g, h. So we'll see how we can use this U, V, W, and FGS to find out the expression. For now, we remember FGH for the Cartesian, it is 1, all are 1. For spherical, F is 1, G is R, H is R sin theta. And for cylindrical, F is 1, G is rho, and H is 1. So if you see, these are nothing but so FGS is nothing but the coefficient of the small length element. Like if you say, recall the Cartesian, we have um, dx, dy, and dz, right? So in Cartesian, this is dou x, dou y, dou x. The coefficient of dou x here is 1. Here is also dy is 1 and dz is 1. But for the cylindrical, so if I see here cylindrical, dou rho it is 1. That is why we say f is 1. And for dou phi it is rho. So that is why we say in cylindrical we have taken this is rho, g is rho. And for the h, the coefficient of dou z is 1. So that is why h is 1. And for spherical, if you recall, FGH is 1 r sin theta. So these are nothing but the coefficient of dou r, dou theta, and dou phi. So this is how you can remember what is the f, g, and h for the different types of coordinate system. So using this parameter u, v, w, and fgs. So if you want to find out the gradient, so you just have to remember this formulation. So for any types of coordinate system, if you want to find out the gradient, it is nothing but 1 by f dou phi by dou u, uk, 1 by g dou pi by dou v, vk, and 1 by h dou pi by dou w, w. So you can replace f, g, h for the Cartesian using this, and u, v, w you can use this. Similarly for spherical, use UVW is r theta phi and FGS is 1 r sin theta. Okay, so this is for the gradient. And for the divergence, the cumulative expression is 1 by FGH dou by dou u, GH AU. So if you see, divergence acts on a vector function. So that means it can have AU, AV, AW. So that is why you can here you can write it as dou by dou your GH multiplied by AU, FH AV, and dou by dou W of FG AW. Curl, just refer to this formula to find out the different types of expression for Cartesian, spherical, and cylinder. So you don't have to remember all the formulation. You just have to remember what is the cumulative expression. Just put the expression for F, G, H, U, V, W to find out what curl expression. Okay. So this is for the Laplacian operator. So just go through the formulation. And the other thing that we've seen is the two types of fundamental theorem. One is Stoker theorem, which relates the line integral with a surface integral, and other thing is the Gauss divergence theorem, which relates the surface integral with a volume integral. Okay, so Stokes theorem it tells whenever you take a closed integration around a path. So if you path like this and you take a closed integration like this, so this is equivalent to taking the curl of the operation A in the surface in this given surface. Okay. Similarly, for divergence, it says the total flux through a closed surface. It is equivalent to taking a divergence of the volume integration of divergence of A. So just we use this formulation in our future lab session. Okay, so these are all about whatever the concept that has been taught in week 2. I think in our previous lab section, I have not solved three problems were remaining. So we'll try to solve that. Okay, one student ma'am I have done divergence theorem. So you have okay. So I will try to clarify doubts, but it will be better if you show me the steps. Like if you tell me in what step you are having the doubts. So you have the Google group, right? So in that you can write a mail that you have a doubt in that particular step. So you can write your own steps and you can just point out where in what step you are having the doubts. Then I will try to clarify that. For now, I don't have. It's difficult to recall what were the steps. So maybe in our next lab session, I will try to cover it. In the meantime, please write a mail in the group so that I can go through it. Uh, Okay, so let us try to cover few problems that is related to week 2. So we'll start from easiest problem, then gradually we'll move to our more difficult problem. Okay, so this is our first problem. It is says there is a function phi which is a, so please try to cover side by side so that you can also cover the steps, or if you have any doubts in one of the steps, then you can easily ask me and for. So this is the function given. You have to find out what is the gradient of this function at 1, 1, 1. So I think you can easily find out what is the gradient. So please remember del operator, or you can write it as del this. In Cartesian, you have I cap dou by dou x, j cap dou by dou y plus k cap dou by dou z. So solve it and let me know the answer. The option is 2x cap plus 3y cap plus z cap. Option B is 2x cap minus 3y cap plus z cap. C is 3x cap plus 2y cap plus z cap. And option D is 3x cap minus 2y cap plus z cap. Anyone? So if you remember, there is a difference between total derivative and the partial derivative. So partial derivative will only act on the function that is it is referring to. Okay, option C. Okay, so this is correct. One if we have already solved it. So let me quickly go through the steps. So phi is given x square, sorry, x cube, y square, z, right? So this will give I cap dou by dou x of y square z plus j cap. So y square z, it will come out the integral, sorry, the partial derivative. So x cube will give 3x square. Uh, y square z plus the second part, y square will remain inside, x cube and z will come outside. So this will give 2y x cube z j k plus for dou by dou z, these two xy will come out. So we have x cube y square dou z by dou z is 1 kk. So to find out the gradient in 1, 1, 1, we just need to put what is the value for x, y, and z. So all are 1, so this will give 3ik plus 2jk plus ak. Or so the answer ik is x cap, y cap, and z. So option C. Please feel free to stop me anytime if you have any doubt in any of the steps. Okay. Okay, so let us see our question number 2. It's given there is a vector function A with expression 3xy z square x cap plus 2xy cube y cap minus x square yz z cap. And the question asks, what is the divergence of this vector field at 2, 1, 3? Four options are given. A is 25, B is 35, C is 45, D is 55. Please solve it. We need to find out what is the divergence of A at 2, 1, 3. So if you recall, this will act component wise. So you will have dou x, dou by dou x, dou by dou y, ay, plus dou by dou z, az. Ax, ay already given. This is x, ay. This is az. Now finding out the derivatives is easy. Option B, yes, it's correct. This is 3xy z square x plus dou by dou y 2xy cube dou by dou z minus x square y z. So this will give 3y z square plus 6xy square minus the square root. And for the given point, which is 2, 3, we will have 3, 1, 3 square, 1 square minus. So total will be 27 plus 12 minus 4. This is 34. So answer will be option B. Okay, so let us see our next problem. It's given there is a vector operator, vector function, which is 2x square x cap minus 3y z y cap plus x z square z cap. So you need to find out. So phi is also given. This is 2z minus x3y, and it's asking you to find out what will be the dot product of A with the gradient of phi at 0.110. Solve it. First option is -3, second option is -4, third option is -5. and fourth option is -6. If you remember, delta phi is nothing but for Cartesian is 4 by dou x by j cap dou phi by dou y plus k cap dou phi by dou z. Phi is given, so 2z minus qy. So that means we'll have dou phi is I cap 2z minus qy plus j cap dou by dou y upon 2z minus qy plus k cap. So this will give my sorry, minus x cube j cap plus k cap. So now we can take a dot product of the gradient of I. So A is already given. These are the expressions. So A d phi it is x dou phi x plus ay dou phi y. Okay, one of you have already saw answer is option D. Okay, it's correct. So it's a dou phi z. X is it is already given. This is 2x square. Ay is 3yz minus 3yz and az is x z square. So 2x square ayz x cube plus x z square. So this will give 6 to 4y plus 3 x cube yz plus 2x z. So now if you put the value 1, 1, 0, right? So you will get this will come out -6. So answer will be option D. Okay, so this is all about question number 3. For question number 4, there is a force field is given. You need to find out what is the work done in moving the object in the field from 1, 1, 1 to 0, 0, 0. So let me write what are the expressions given. So for the force, it is given 2xy plus zq x cap plus square y cap plus 3x z square zk. So you need to find out the work done in between the points 0, 0, 0, and another one is 1, 1, 1. So to give you it, you just to recall work done is nothing but the total force that has been that is required while going through path D. So this you can write it as some gradient of pi with D. And this is you already know this is nothing but D flow. So if you take the integration of d phi, this will come out as phi. So if you somehow know what is the expression for phi, then you can easily find out what is the total work done. So how you can express this and this. So depending on the function behavior, so it is written in terms of Cartesian coordinate, right? So you can take the small element, the dl or the small surface element in terms of in that coordinate. Like if it is written in terms of Cartesian, just take Cartesian. And if it is written in terms of spherical, just take spherical. And sometimes you also have to interchange it because in some of the problems you will find that taking spherical is better than taking Cartesian. Okay, so to solve it, so we have D5, it is nothing but FDL, right? We just want to find out what is phi. So FDL is F is given to 2xy plus zq dx plus x square dy plus 3x z square dz. So this is 2xy dx zq dx plus dy. So if you see, if you rearrange these terms, like if you take 2xy dx plus x square dy plus zq dx plus 3x z square dz. So if you see this is nothing but the derivative of x square y. And this is the derivative of x z. So derivative of this will give these two terms. Derivative of this will give these two. So this is like taking the derivative of this function x square y plus x z cube. So now you know what is phi. How you write this formula. So which one you are referring to? Uh, do you mean this formula? This work done. So it's like it's the definition of a work done. So if you know the force and if you find out the line integral, then this is what we call what is the work done while going from point A to point B. So this is the definition which is used. So are you talking about this or mm, this one or this one? One, two, three. F2 delta phi. Okay. So it's like expressing the 2 and 3. Okay. So it's like we'll see in the latter lab section. It's like whenever you have a force, you can if we can write it in terms of some gradient of some scalar. So this is one of the way. It's not like you just have to follow this type of process, this kind of steps, but this is one of the easiest way you can find out what is the voltage. So you can do another, you can take other type of methods that you can find that you are comfortable. But for this, what I have done, so if you can write function, so if there is a scalar function f, for which, so for, sorry, there is a scalar function phi for which you can write f as gradient of phi. So gradient of phi always gives a vector quantity. So that is why I have taken f as delta phi dot d. And this is the definition for d phi, right? So if we function like this, you can write it as gradient of phi dot product d. And for this, you can easily see if you can find out d phi, then by taking the integration of d phi, it will easily give what is phi. Can any vector function be written in terms of gradient of some scalar? So it's an interesting question. So it's not like that. You can't write any vector function in terms of a gradient of some scalar. So whenever you have a, we'll see in later course. So whenever you have a conservative force or conservative field, for that case you can write the function f in terms of some gradient of some scale. So if you have a conservative force, you can always write it in terms of some gradient of some scale. It should be path independent, right? Yes. For conservative force, it is path independent. So beware of this definition for non-conservative force like the friction force. These are all non-conservative force. But we won't cover that kind of force in electrodynamics. We'll mostly see the conservative force for electrostatic case. It is conservative, but whenever we cover electrodynamics, that is non-conservative. Okay. Okay. So we were trying to cover. So this is one of the method to find out work done. So for this, we have already found out what is phi. So that means work done is phi. Now you just need to put the limit. One is 111, one is 000. And if you put 111, this will give 2, right? So that is why the answer will be option A. Okay, one of so how do we get to know this vector function if we say conservative before checking? Okay, so for that, I think that definition was missing in this problem. So in the problem, it was not written explicitly कि it's a conservative force, but Uh, you can take it as a conservative case. It is a conservative case. It was missing in the question. Sorry for the. Okay. So now I think this will be fine. Okay. So other than this, is everything clear? Other steps? Is it fine or can I move to our next problem? Next problem is it's the easiest one. Okay, so if it is all right, then let us move to our next problem. So it is asking you to find out what is the curl of F in a spherical coordinate system. So it's given F is r theta cap plus phi cap, and these are the four options that is given. So if you recall our general expression that we've seen in first part of our lab section. So let me go to the first page. Here. So to find out the curve, we have this. You just need to recall this formula. And FGH, this we have already covered. What are the expressions for spherical? This is spherical coordinate, right? So F is 1, G is R, H is I think R sin theta. And UVW is nothing but RK, G is theta K, this is phi. So that means curl of F, it will be 1 by R square sin theta FU. FU cap means R cap, then G B cap, sorry, for G is R, so this is R theta cap, and H, which is R sin theta, phi cap. So dou by dou R, dou by dou theta, dou by dou phi, and again we have FAU. So let us see what is the function. So function is written in terms of theta cap and phi cap. So that means we have F theta, which is R, F phi is 1, and F R, this is 0. So that means FAU, that is FAR, it is 0. GAU, this will give R square, and the third term will be R sin theta. Now it's easy to find out the curl. So we just need to do the remaining steps. So R cap dou theta, R sin theta minus dou phi of R square, it will give 0. So let's skip that. For R theta cap, we will have dou R sin theta, and for phi cap, r sin theta cycle q of dou r r square. So these are the shorthand notations. I think you must have known. Dou r means dou by dou r. Dou theta means dou by dou theta. Dou phi means dou by dou phi. So this is just to make the steps easier. So we use this shorthand notations. Okay. So dou by dou theta of r sin theta, it will give r cos theta minus this will give r sin theta theta plus this will give 2r, so 2r square sin theta phi. So just take take this term to the bracket term. So this will give cot theta r r cap minus 1 by r theta cap plus 2 phi. So answer will be option B. Okay. Just go through the steps. I think it will be easier for you to find out. So, and only just remember what are the general expression for finding out a curl or divergence or Laplacian. Okay. So, let us move to our next problem. This is to find out a divergence of R when you are given R is R square sin phi R cap plus R square cos phi phi cap 2rj sin phi in the cylindrical coordinate system. So let me give you the general expression. Dimensions. So this is the general expression. So please try to solve it and let me know your answer. For cylindrical one, we recall F is 1, G is rho, H is 1. And U is rho K, G is theta, sorry, phi ray or theta. W, it is Z. 4R sin phi. Main option A. Yes, it's correct. The answer we'll get is option A. So let me quickly go through them. So del R, this is R is given R square sin phi R cube plus R square cos phi cap plus 2R z sin phi z. This is AR, A phi or arrow A phi, or you can take A theta, then this is AZ. So divergence of R will be 1 by R dou R dou phi Z. So 1 by R dou R of R dou sin phi R square cos phi dou Z 2 R Z sin phi. So this will give 3 R square sin phi by R plus R minus sin phi plus 2R sin phi. So that means this is 4R sin phi. Okay, so this is question number 7, I think, or 6. So let us see our next problem. So it's given a vector function A 2x z square x cap minus yz y cap plus 3x z cube z cap. Another scalar function is given, x square yz. You need to find out what is curl of phi A at point 1, 1, 1. And these are the 4 options. Quickly solve it. Cartesian finding the curl it's easy. So if you even don't know the general expression, then we can easily proceed. So to, to the steps, this is X cube, Y cube, Z cube, dou X, dou Y, dou Z, 2x cube, Y, Z cube, minus X square, Y square, Z square, and this is 3 X square by Z y 4. So dou y, this will give 3 X square, this will be X cube. So now this will give dou y by dou y. So this will give 3x cube, Z power 4. And this one it will give plus Z y square. X cube minus for y, dou x of this will give 9x square y z power 4 minus dou z of this. This will give 6x cube y z square. Right. And this will give minus 2x y square z square minus this one will be 2x cube z cube. So the point is 1, 1, 1. So that means this will give 5x cube, 5x cube minus 3y. There is a term 2 missing here. Then this will give 3y cube. This will give minus 4y or z cube. So answer will be option, let me see, 5, 3, 4. Option B. Okay. So, okay, so this I think anyone can solve. Let us try to see our next problem. For this problem, you have to find out what is the line integral of a vector function A given. So, given the vector function is ax square plus 6y x cap minus 14 yz y cap plus 20 x z square z cap. A is given and it is asking to evaluate A dot dr from 0, 0, 0 to 1, 1, 1 along a straight line. So we are covering a straight line which joins these two endpoints. This is easy, right? So let me know the answers. Option A is 11 by 3, option B is 13 by 3, option C is 12 by 7, and option D is 14 by 7. So how you can do it? Okay, so if it is taking time to solve it, so let me quickly go through the steps. Okay, so this is like in the Cartesian coordinate, we'll have the integration ax dx, ay dy, and az dz. Ax, ay, az, these are given. And one thing you can notice in the problem, it's given we are moving through a straight line path from 0, 0, 0 to 1, 1, 1. So that means for this straight line path, we are moving in a direction for which x equal to y equal to z. So that is why we can take dx equal to dy equal to dz. So now the integration will be only on one variable. So ADR, this will give the 3x squared plus 6y dx minus 14yz dy plus 20x z squared dz. X, Y, Z are all same. Means you can write it as C 3x squared plus 6x minus 14x squared plus 20x cubed dx. So you have, so x is varying from 0 to 1, and this is 6x minus 14 plus 3, 11x squared plus 20 cubed. So this integration, I all of you know, this will give 6x squared by 2 minus 11 x cubed by 3 plus 20 x 4 by 4. In the integration limit is 0 to 1. So if you put the upper and lower limit, you will get a value 13 by 3. Just check it if you are getting this or not. So answer is option B. So is this problem clear? Or do you need me to go through any of the steps? Just let me know. Okay, so if no doubt is there in previous problem, let me move to our next question number 9. So in question number 9, it is asking you to evaluate what is the double integration of this function over a surface S in a region R, which is xy plane bounded by given x square plus y square is 46. So for this surface, you need to find out what is the value for this integration. So try to solve it first, and I will go through the steps. Okay. So there is a surface xy is given, which satisfies this condition x square plus y square equal to 36. For this surface, you need to find out what is the value for this integration. Just look at the expression. Like if you are seeing any familiar coordinate system that you can use for this integration. So it's not like always the Cartesian will be used here or cylindrical or spherical. So depending on whatever the shortest route you can use, you can easily use that coordinate system. So in all coordinate system, it will give whatever coordinate system you will take, it will always give the same answer, but the steps will differ. I think everyone can solve it. So please let me give you 2 minutes. If not, if it is taking more than 2 minutes, then I will try to solve. Okay, so let me. So, can anyone please tell what coordinate system you can use it here? Is it Cartesian or is it spherical or is it cylindrical? What is the first coordinate system that you can use? So, if you see this expression like x square plus y square equal to 36, right? So, this is the equation of a circle, right? So, whatever surface you have, this satisfies the equation of circle. So, that is why you one thing that should come your mind, you can use the spherical or the Cartesian. In spherical, the theta will be pi by 2. Sorry, spherical or cylindrical. So if you look at the cylindrical one, like for cylindrical coordinate system, uh, for a circle, what is the expression for this area element? A small area element, which is at an angle r, and this is theta. You want to find out this expression for this small area element. So this area element, it is nothing but ds, which will be r r d theta. Sorry, r d theta dr. So if you zoom it, this length is r d theta, this is dr. So that is why the area element in this direction is r d theta dr. And this expression x square plus y square, it is nothing but the area, the expression for the circle, right? R, you can write it as square root of x square plus y square. So that is why this total integration x square plus y square ds, this simplifies to r r d theta d. So now you know the limits. For r, it is 0 to capital R, like what is the maximum value of radius. And for theta, it is total circle. So this will be 0 to total full circle. So this is 0 to 2 pi. So this will be d theta integration will be give 2 pi. And this is r square dr. So 2 pi r square will give r cube by 3. And the maximum value of this radius, you can get it from the equation of circle. So it is 36. That means r square is 36, r is 6. So this will give 2 pi 6 by 3. So that means this is, I think, sorry, 6q, right? So this will give 144 pi. Okay, answer will be option D. So is the question number 9, it is clear to you? Do you have any doubts in one of the steps? So for this case, we just use the cylindrical coordinate system to find out the shortest route. You can also verify, you can use the Cartesian also, but for that case, it will take few more steps to find out the answer. So, but The answer will get that case also it is 144.5. So any doubts in this question? Otherwise, we'll move to our next problem. Okay, so for the next problem, let me solve it. It's given f, it is 2x squared minus 3z x cube minus 2xy y cube minus 4x z cube. And it is asking you to evaluate what will be the uh, volume integration of divergence of f in a volume V. And this volume, it is made by four planes. One is x equal to 0, y equal to 0, z equal to 0, and 2x plus 2y plus z equal to 4. So these four planes makes the volume V. And for this volume, inside this volume, you need to find out what will be the integration of this function f. So whenever this kind of problems is given to you, it is always a good practice. So you have three variables here. Find out what is the limits, what is the minimum value and maximum value of a one of the variable. What is the maximum limit or minimum limit of one of the variable? And for other two variable, try to write it in terms of the variable that is for which you know the limits. Okay. So what I mean is for this case, there are three variables, right? X, Y, Z. What you need to do, you just need to find out, let's say, just find out what will be the maximum and minimum limit for X. After that, just try to find out what will be the maximum and minimum limit of y in terms of x. Then try to find out what will be the maximum and minimum limit of z in terms of x. So why we are doing this? It's like this is a volume. So these parameters are interrelated. So that is why if you know one of the variable maximum minimum limit for one of the variable, the other limit they depends on the previous limit. What is the maximum value of that x can take for a given surface? Okay, so you can take x, find out the maximum or minimum limit, or you can take y also, or you can take z. But you have to follow a systematic process. Like if you find out z, try to find out either y or x in terms of z. Then for the third variable, try to write in terms of the other two variables, y and z. So let us find out what is the maximum and minimum limit for x. Then we'll write y in terms of x. We'll find out the limit of y in terms of x, and we'll find out z in terms of y and x. Okay, so for this, if you see the plane z equal to 0, for z equal to 0, what we have, so if you see this plane, 2x plus 2y plus z equal to 4. So what will be the maximum value of x for this plane? Maximum value will be for the case when y equal to 0 and z equal to 0. So that means 2x is 4, x is 2. So this gives that the values for x, it can vary from 0 to 2. For y, what will be the expression? So for y, when we are considering the z equals 0 plane, so this is 2x plus 2y is equal to 4. So this will give y is 2, 2x plus 2y whole minus x, right? So this that means the y value, it can vary from 0 to 2 minus x. For z, this is also easy. This will vary from 0 to 4 minus 2x minus 2. So we first find out what is the maximum value of x using the plane, whatever the equation given for the plane. Then we write y in terms of x and other variable in terms of x. Okay. So now the finding out the integration is easy. So this is divergence of f dv, right? So f is given 2x square minus 3z x cap minus 2xy y cap minus 4x z cap. So divergence of f, it will be dou x of x dou y of y plus dou z of z. So this will give 4x minus 2x, which is 2x. Okay. So now the volume integration is 2x dx dy dz. And the limits are for x it is 0 to 2, for y it is 0 to 2 minus x, and for z this is 0 to 4 minus 2x minus 2y, 2x dx dy dz. So try to solve the unknown parameter first, like the unknown parameter, so what I mean is unknown variables. So z is written in terms of xy, y is written in terms of x. So that is why try to solve the dz and dy integration first. Then we will take the integration of x. Okay. So we have x 0 to 2, y 0 to 2 minus x. And dz integration, it will give z, right? So that is why we will have dx z, which is 4 minus 2x minus 2y dx dy. So now we'll solve the dy integration. So for this, equal to 0 to 2, y is 0 to 2 minus x. So let us see the, this is 8x minus 4x squared minus 4x dx dy. So this will give, so 8x dy, it will give 8xy minus 4x square dy will give 4x square y minus 4xy dy will give 4xy square by 2. And the limit is from 0 to 2 minus x dx. Okay, so just put the value of y. So this is 8x, y is 2 minus x, 4 x is 4, 2 minus x, 2 x y square. So just simplify it. You will get x equal to 0 to 4, 8x minus 8x square plus 2x cube dx. So now this is easy to solve. This is only the integration of x. So this will be, so I'm writing the final value. It will be 8 by 3. So the answer will be option D. Okay. Okay, so for what I have done, so to get the maximum value of x, so so one of the plain expression it was given 2x plus 2y plus I think 4 or plus z equal to 4. X I think it's clear. We just need to put y is 0, z equal to 0. So the value for the x is 4, sorry 2. So maximum value of x is 2. Now to find out y in terms of x. So now we are also maximizing y, right? So for that, what we have done, so we want to find out y in terms of x. So we have kept 2x, 2y, and z for the case where z equal to 0. Then for that case, y will be maximum, right? So that is why I put z equal to 0 here, and we are getting 2x plus 2y is equal to 4. So y will be 2 minus x. This is the maximum value of y in terms of x. Uh, Now for the z, for z we want to write in terms of x and y. So that is why we have taken the whole expression, like 2x plus 2y plus z equal to 4. So z will be 4 minus 2x minus 2. So this is the way that if you want to start from x, you can start from y also. For that case also, you will get the same answer. So the answer will be 8 by 3 only. So we have, okay, so to reiterate, one of the plane of this volume is 2x plus 2y plus z equal to 4. And other planes are x equal to 0, y equal to 0, z equal to 0. So that means the minimum value of x, y, z all are 0. So there are planes where x is 0, y equal to 0, and z equal to 0. But we don't know what is the maximum value of x, or let's say y, or let's say z. So for that case, so I'm following. I want to find out. I want to start it from x, then I will go to y, then I will go to z. So to find out the maximum value of x, what I have done, I have just so the x will be maximum for a point where y is 0 and z equal to 0. So we'll get a point in that volume, right? So that is why we'll get 2x equal to 4, x equal to 2. So maximum value of x is 2. For y, but I want to write y in terms of x. So that is why I haven't, I have kept the value of x here to y, and we'll get a point where z equal to 0. So for that case, the y will have expression 4 minus uh, x, 2x, 2, so 2 minus 2x, and z will have the usual expression. So for z, we want to write it in terms of x and y. So that is why we have kept 4 minus 2x minus 2. So I hope these are clear, or otherwise, let me know. You can check also if you want to start it from y. Can you please explain these steps for Griffith example 1.83? Uh, so example 1.8. Let me solve it in our next live session. Otherwise, I won't be able to solve other problems. So I will solve it in the next. So you mean 1.8, right? Example 1.8 or problem 1.8? I think your example 1.8. There is nothing such like example 1.8. Example. So I will remain the eighth question. Prism question. Okay, so I think it's better if I will see it on next. Okay, so let me say, I think you mean this problem. This is the problem you're saying. I think this can be done by maximum three portion of the plane rate. This can be done that way also. So for this plane, what you have, you can find out what is the expression for this plane. I think that is also not necessary for this case. So there are different ways of finding out the answer to a given problem. So for this problem it is given is x, but the equation of this plane it is not given. So what has been done in this solution is like we just I think they have just find out what is the equation of this line, which is y is minus x plus 1, and they have integrated over Okay, so let us see how we can follow the same steps that we've used here. Okay, we can easily find it. So all the process will give the same answer, but it's like whenever you are uh, trying to solve a problems, so you always think of finding the shortest route, right? So the answers that is given is one of the shortest route. Otherwise, you can follow the other methods. Okay, so now let us move to our next problem. For this, you need to check whether the curl theorem, the Stokes curl theorem, it is satisfying for this surface given here. So if you recall, the Stokes curl theorem is like curl of V dot dA, it should be equal to V dl P. So you need to check whether the LHS side is equal to the RHS side. I read it out in problem 1.31, not this quantity other question. 1.31. Okay, I will keep this in my mind. We'll try to cover this problem in next lab section. Okay. So is it fine with you? Question number 31. For this, corner points are given and one function is given, and you need to find out the volume integral. Okay, so for this, let me give the proof. So it's given function v, which is 5xy square I cap plus yz square j cap plus 4x square z k cap. So let us find out curl of v first. So curl of v, so I'm writing the uh, final expression that we'll get. So just you just need the in between step whether this is correct or not. So for this we'll get 2yz x cap minus 8xz y cap minus 10xy z cap. So if you want to find out what is the flux, that is not flux, what is the integration over the area A. So dA for this case, it is d by dz, right? So that is why dy dz and the vector is in the x direction. So dot product will only pick the x component of column B. So this will give 2yz dy dz. Okay. And one of the equation is given. This path, the curve path, it follows z equal to 4 minus y minus 2 whole square. So that means for this two variable, you can write it in terms of only one variable. So minus y you will get. So just check the steps whether you are getting or not. So let me write the first step. So here you get 0 to 4, 0 to 4 minus 9 is 2 whole square 2yz dy dz. So first we'll try to solve for z, then we'll try to solve for y. So 0 to 4, this will give y 4 minus y by y minus 2 square dz. So for this we'll get minus 1024 by 15. So this is the answer for the LHS side. For the RHS side, we need to find out the line integration. So that means we have to go through this, then this part. This is part 1, this is part 2. So for part 1, we have x is 0, right? And z is also 0. So dl is dy right for this part. So vdl, it will be yz square dy. So because z is 0, this will give 0. So for part 1, we have vdl is 0. For part 2, this part, we have dl is both a function of dy and a function of dz. And x equal to 0 because this is a yz plane, and z is 4 minus y minus 2 whole square. So if you want to find out vdl, this will be yz square dy plus 4x squared z dz. And because x is 0, this term will be 0. So we are left with y z square d. Z square, z expression is given 4 minus y minus 2 whole square from 4 to 0. So y is going from 4 to 0. So this, if you find out, this will give 1024 divided by 50. So that means this is equal to the LHS. So the Stokes-Kull theorem is verified for this function. Okay, so I think this may be the last question. So can you please go through the question? It's given to find out what is the curl of gradient of t, whether it is 0 or whether it is 1, or it cannot be determined, or it depends on the function t. So what will be the answer to this question? depends on the function t. No, it's not correct. So divergence of, sorry, curl of gradient of any function is always zero. So we'll use this concept in our next lectures. So if you can just follow the same procedure. Just let's say we are checking it in the Cartesian one. So this will be dou by dou x, dou by dou y, dou by dou z. And we have dou t by dou x, dou t by dou y, dou t by dou z. So this will be dou by dou y, dou t by dou z minus dou by dou z, dou t by dou y. So you can see here these are equal. So that is why this is already zero. Similarly, you can check it for y cap also. Y cap, it will give minus y cap, dou by dou x, dou t by dou z, minus dou by dou z, dou t by dou x. So this is also zero. Similarly, for the z component also, you will get zero. So that is why we say the curl of gradient of any scalar function is always zero. Answer will be option A. Similarly, we will see also for when you take divergence of a curve, it will also come out as zero. So if you are taking divergence of a curve, this is always zero. Okay. So I think we'll stop now. There are few more problems. I will try to cover it in our next lab section. And also three problems were remaining for the first lab section, like 15, 16, and 17. So I would suggest please try to go through the solution first. The solutions are already uploaded in my Google Drive link. So please try to go through the solution. And if you are having any doubts, let me go through in our next lab session. And for one of you, the question was about problem 13 and some of the steps from the lecture. So please try to write a mail in the group about exactly at what step you are getting the doubts. Okay. So if you post it in the group, then I will go through the uh, steps you are doing and will let you know the what are the missing steps or what are the doubts. Okay. So any other doubt you have for the problems that I have solved today? Yes. So you are asking for every function which are independent of the path, which can be written in terms of gradient of some scalar, it will be irrotational always. Yes, it's always true because you can see it here also. Mm, so where is it? So you can see the Stokes curl theorem here. Sorry. So one thing we have seen now is the curl of the last question that I made. The curl of is gradient is always zero, right? So if you look at the this for okay, let me write it explicitly. So ADL is equal to curl of A ds. And if you take the close integration of a conservative vector or conservative force around a path, then it will always come out as zero, right? So that means this part will also zero. So for conservative force, this means curl of A is zero. And curl of A is zero means we can always write A in terms of some gradient of some scale. So that is why we also check the fundamental principle that curl of gradient is always zero. So these are all interrelated. Okay. So any other doubt you have? Any one of you? If you have any doubts, let me clarify it first. Then we will end our lecture. Uh, we take few graphics and problems. Okay, so if you want me to solve the graphic, then the next live session I will try to solve uh, only the problems that I will think it is important for you. Okay, I won't try to cover all the problems, only the problems that may be tricky, then I will try to solve it. Then if the time permits, then we'll see few more problems. If any other doubt? Google Form, it's not like that. It's like there is a group for this course. So let me see it first. So you have to join that group, and in that group you can ask any of your doubt. You can ask any of your doubt. Um, where is it? Okay, so if you see the course website, there is a tab Q&A tab, not Telegram. So if you see the course website, so there is a Q&A tab there. So you have to join that. So there is an announcement then about the course, Q&A, progress, mentor, review assignment, course recommendation. So that is the tab I'm going. I'll stop. Okay, let me share my screen. Then I think it will be easier for you. So is my screen was okay? So I'm in this tab Q&A. So there is a discussion forum for this course. You have to join that. And in that group, you can write your any of your doubts. Few of you have already joined the session, joined the group. So this is the group I was talking about. So you have to join this group. Okay. 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 So let us end our live section. So thank you for joining the session. I hope the problems are clear to you. If not, feel free to ask me in our next live session. We'll meet on next Friday, same time from 6 to 8. So, so let us meet in our next live. So thank you everyone.